Well, good morning, everyone. As you can see, it's the bonus quiz for 6.8. Two questions, 2 points, and that's good because the section itself divides itself into two prominent themes. The first part of the section deals with formulas and solving those formulas for particular variables. And so that's what my problem 1 here is. They're asking us to solve this here for g. Now, we've already solved formulas for variables, and that was in section 1.4, but we did not have, if you just look at this side right here, we did not have any fractions in those formulas. And the idea here, the bigger idea, is that every profession on earth has formulas, and you may need to solve for a particular variable in that formula on your job. So could you isolate g here? That's what they're asking us to do. And really all we do now is undo what's being done to g. And what's being done to g as we look at it is it's being divided by two quantities. And so we're going to multiply by those two quantities. We're dividing by k, so we're going to multiply by k. And of course, since we have an equation, what we do to one side, we have to do to the other side to maintain balance. We're also dividing by this quantity, so we're going to multiply by that quantity, z minus y. And we will do that to this side as well. And at that point in time, things become strikingly apparent. The multiplication does the division in both cases, and we've isolated for g, which I'll write on the left-hand side because that's the normal way of doing things. And then we have these three numbers being multiplied together. And so what's the best way to write that? And I think it's this. This is what I'm going to type into, well, actually I already typed it into MathXL. KQ times the quantity z minus y. Now I know we could do this multiplication, but that represents a step backwards. In other words, we are in factored form here. This thing has already been divided, and since division is harder than multiplication, leaving it in its factored form, that's problem 1. So let me do a close reading of this problem. It says to find an equation of variation. And that's what they want. Find the equation of variation and type that in here, where y varies directly as the square of x, and where this ordered pair satisfies the equation. And so I've written these two values as an ordered pair right here. And so, depending upon the problem, you either get direct variation or inverse variation. I got direct variation, and so we're looking at this template. And the game here is to use this template and maybe make some alterations to it to meet the needs of the problem. And I do need to make some alterations because they're saying that y varies directly as the square of x, not just as x, which is what this says, but directly as the square of x. And so this is the template we're going to use in this particular problem. Now, before I make my substitutions in for x and y and solve this, let me just point out something here. Inverse variation looks like this. And if this had said y varies inversely as the square of x, then we would have had to alter our formula like so by putting a square there. This particular relationship between x and y is fascinating. You'd be amazed at how drastically the equation changes when x goes from being a multiplier to a divider. And if you have a chance, you might want to check out the graph of that. Consider that to be the primitive template with k equal to 1. And you'll be amazed at the graph that gives. Okay, so we have direct variation where y varies directly as the square of x. Here's our template. And the game here is to use the values that they gave us for x and y and sub those in. Now, they told us that y is equal to almost 1 and that x is equal to 0.1, and of course that's being squared. And so the game is to solve this for k, which we can easily do by dividing both sides by 0.1, and we would get this, 0.99 divided by 0.1 times 0.1. There's a reason why I'm setting it up this way. I know you could run to your calculator and do all this, but I like to get the numbers going because we want to be number smart. I wanted to just ask you how to read this out loud. And hopefully you're saying to yourself right now, 1/10. And so really what we have down here is 1/10 times 1/10. Here, this is really 0.99 over 1/100th. And so if you saw my video on drop the denominator, you know what happens is that this comes up as a multiplier. And whenever you multiply something by 10, you move it one place. When you multiply it by 100, you move it two places. And so we're going to get 99. And so again, they're asking us for an equation of variation. After you've done all this, after you've found your k, don't stop. You want to rewrite the equation. It's going to be 99 times x, and of course it was very directly as the square of x. And so that's the answer that we're going to put into MathXL. It's going to be 99 times x quantity squared. And let's do a submit. So there you go, and good luck on the exam. One of these will be on there, at least one, and I think you'll nail it because these are pretty simple once you get the direct and the inverse templates firmly fixed in your mind.